In today's video, we'll be looking at the general form of a single replacement reaction. I also hope you'll understand how to read the activity series in order to predict the products of a single replacement reaction, and that you can predict the products of that reaction with 100% accuracy. So as a reminder, a single replacement reaction has the general form of an element plus a compound yields another element plus a compound. So our two positive ions are going to swap places in this reaction. In order to determine how or if those positive ions will swap places, we are going to use the activity series. And it looks like this, where the metals towards the top of this series are more reactive than the metals towards the bottom of the series. In our first example, we have zinc plus silver nitrate. So let's first confirm that this is a single replacement reaction. We have an element, zinc, plus a compound. This is, in fact, single replacement. So to predict what will be on the right side of the equation, or the products, we need the activity series. Let's go ahead and find the metals, or the positive ions, which in this case are zinc and silver, over on the activity series. So we're looking over here. We find zinc in this location and silver towards the bottom of the chart. This means that zinc is more reactive than silver. When we look at our equation, our reactants, we want the element that is by itself to be higher on the chart or more reactive than the element it wants to replace in the compound, which in this case is silver. So, because zinc, which is the lone metal, it's over here by itself, is more reactive than silver, which is the metal in the compound, this reaction will occur. So let's predict the products. Since this will occur, the zinc is going to swap places with silver, and it's going to combine with the nitrate. Remember, zinc has a charge of +2 and nitrate has a charge of -1. We needed to check the charges because zinc plus nitrate is an ionically bonded compound, so we must balance the charges, which means it will be written as ZnNO3 2. That leaves silver by itself, so plus silver. But before we finish, we must balance the equation. So to do this, we need to add a 2 here before AgNO3 and a 2 before Ag. In our second example, we have Ag plus KNO3. We need to, again, check to see if this is single replacement. We have an element plus a compound, which means we have to use the activity series. So let's find the positive ions, or the metals, which are Ag and K. So Ag is down here towards the bottom of the chart, and K is at the very top of the chart, which means K is very reactive, but silver is not as reactive. Remember, the element that is by itself needs to be higher on the chart than the element in the compound in order for this reaction to work. However, because silver, which is the lone metal, was less reactive than potassium, which was the metal in the compound, this reaction will not occur, and we simply write no reaction. So in today's video, we looked at the general form of that single replacement reaction. We learned how to read the activity series, and we actually predicted the products for two different single replacement reactions.